All right, let's look at an example of a hypothesis test, and this will be combining all of the steps from beginning to end. All right, waiting on hold, single sample mean. So a company that claims the average time a customer waits on hold is less than 5 minutes. A sample of 35 customers has an average wait time of 4.78 minutes. Assume the population standard deviation for wait time is 1.8 minutes. Test the company's claim at a significance level of 0.05 by comparing the critical value versus the test statistic and the significance level versus the p-value. All right. So just like how I like to begin every problem is let's look at the information that we were given. This would be step one. Okay, so let's see here. A company claims that the average time a customer waits on hold is less than 5 minutes. So what we've got is we've got an average, so that's going to be a population mean, is less than 5 minutes. So that is our original claim. A sample of 35 customers. Okay, so a sample of 35 customers. So we know that sample size is 35. Has an average wait time of 4.78 minutes. So our sample average is 4.78. So our sample mean is 4.78. Assume the population standard deviation is 1.8. So the population standard deviation is 1.8. Test the company's claim at a significance level of 5%. So here we know that sigma equals 0.05. And I guess from that, we could say that we're dealing with a confidence level of 0.95. All right. So we want to test this company's claim that the average time a customer waits on hold is less than 5 minutes. We want to know whether that is, we want to test that claim. Let's just put it that way. Okay. So what we're dealing here is we're dealing with one sample mean and the population standard deviation is known. So that implies that we're going to be using a normal distribution. And since we're using a normal distribution, that's going to be using z-scores. All right, now let's move on to step two. So step two is to set up the null and alternate hypotheses and all the other things that go with it. So remember that the null hypothesis and we've got the alternate hypothesis. Now the alternate hypothesis does not have inequality in it. And what we did is we took our claim and we converted that into a mathematical or an algebraic inequality, and we got this. So notice that the inequality that we're using is just less than. It's not less than or equal to. So because it's less than, that's going to be our alternate hypothesis. And this was our original claim. So remember to write this down at the very beginning. Okay, so then our null hypothesis It's going to have the same variable and value, mu and 5, but now we want to do the complement of less than. So that will be greater than or equal to. Okay. Um, so the last thing we need to get from this is looking at the alternate hypothesis, what tailed distribution are we going to be dealing with? And remember, you want to make an arrow out of this. So it's an arrow going to the left, which means this is indicating that we're going to have a left-tailed distribution. Okay, so now let's move on to step 3. So step 3 is to calculate our test statistic, our critical value, and significance level divided by 2 if we need it. All right, so in order to calculate our test statistic, remember that the z-test statistic normally had a formula. Okay, and that was at the very beginning, I think, of this chapter. But instead of using this formula, we're going to use a z-test calculator function. And so what I've got here on the right-hand side is screenshots from the Texas Instruments and the NumWorks calculators. And you can see the values that each of these calculators needs. So let's kind of scroll down to include these things. So on the Texas Instruments, let me go ahead and fill these in. But we'll do it with the actual calculator here in a minute. So with the Texas Instruments, you can either input your sample data if it's given to you, or your sample statistics. And with this screenshot, we're going to be using statistics that were given to us about the sample. So we were told what the sample size was. We were told what the sample mean was. We didn't get like a list of numbers. We didn't get a data set of our sample. Okay. If we'd been given a data set of our sample, then we would have chosen data and it would have asked us for a list. Okay. But we didn't get a list of data of our sample. Instead, we got statistics of our sample. So this mu naught, what it's asking for is it's asking for this value of 5. We have a population standard deviation of 1.8, a sample mean of 4.78 with a sample size of 35. Now, this last option at the bottom is it wants to know what is your alternate hypothesis. Well, the alternate hypothesis is less than 5. So you're going to want to select that and hit enter. Okay. Now on the NumWorks calculator, we're going to go to the inference app, go to the one sample option, and then choose z-test. Now the first thing that it asks you with the NumWorks calculator, which operates differently than the Texas Instruments, is it wants to know what's the null hypothesis and what's the alternate hypothesis. Now the null hypothesis, I think it'll change based off of the alternate that you choose. So what we're going to be choosing here is going to be this one, mu less than. And I think it'll ask us for a number. I'm not sure. Let's go ahead and take a look at that because we might as well figure out what it's going to be. So I'm going to hit home And I want to go to the inference app. We want to do a test, not an interval, but now a test. It's going to be of one mean, and we want to do a z-test because we're dealing with a normal distribution. Okay, so this is where we could put in our value, I think. So here I want to put a value of 5. Okay, and yeah, mu is less than. Mu is less than 5. That's my alternate hypothesis. Okay, so I'm going to click next. Now, input statistics or use a data set. So this is very similar to the Texas Instruments. And why not? I'll just kind of go through the Texas Instruments at the same time, just so I'm not leaving you Texas Instruments people hanging here. So let's clear that. Now to get to the statistical tests is you hit the stat button and go to tests. And the first one is a z-test. Okay, and we're not going to be using data. Instead, we're going to be using stats. So notice with data, notice it has this list input. As soon as I switch it over to stats and hit enter, that list input goes away. So now we're going to be putting stats in. Okay, so the value that we're using in our alternate hypothesis is 5. Okay, so we are going to input statistics, and the sample mean, what did I say that was? The sample mean was 4.78. Okay, so I'm going to put 4.78 over here. Let's see here. Then we've got a population standard deviation of 1.8 and a sample size of 35 and a significance level of 0.05. Okay. And let me come over here to the Texas Instruments. So we've got a standard deviation of 1.8, a sample mean of 4.78. So you can see both calculators are asking for the same thing, just in a slightly different order. And our alternate hypothesis is less than 5. So, here it said mu naught is 5, so less than 5, okay? And let me see, I'll leave it at calculate for now. Let me come back over to NumWorks, scroll down, and click next. Okay, so here it's giving me my z-test statistic and my p-value. So now I'm going to hit calculate here. And there's my z-test statistic, negative 0.723, and a p-value of 0.2348 and some change. All right, so that's exactly what we wanted to calculate. So these are values that come from our sample data. So the z-test statistic comes from our sample data, and the p-value comes from our sample data. So let's update what we've got here. Okay, so this had to be a 5, and this had to be a 5. A sample mean of 4.78. And a population standard deviation of 1.8. Sample size of 35 with a significance level of 0.05. Okay, and scroll down. Okay, we end up with a z-test statistic of negative 0.723 and a p-value of 0.235. So let's go ahead and write that information here. So we have a z test statistic of negative 0.723 with a p-value of 0.235. Now, if we were going to calculate this with that previous formula, let me just go ahead and show you what that would look like. So it's x bar minus mu all over sigma divided by the square root of n. So we'll have 4.78 minus mu, which was 5, all over sigma, which is 1.8, divided by the square root of 35. And if you simplify that in your calculator, you're going to get the same value that the calculator came up with, which was a negative 0.723. Okay, now the p-value we're going to calculate on the next page. Again, because I'm trying to use these screenshots, these calculator screenshots, in order to help you work through this. All right. So let's move on here to step 4. So step 4 is to draw and label our distribution figure. All right, so we're dealing with a normal distribution. So I've tried to leave plenty of space so that you can do this too. And what we're dealing with is we're dealing with a left-tailed distribution, right? Because that's what the alternate hypothesis told us, a left-tailed distribution. Okay, so it's left-tailed. So we're going to have a negative z critical score. This area is our significance level, and we know that that's 0.05. And we've got a confidence level then of 95%. This critical value defines the null region on one side and failing to reject the null region on the other side. Okay, now what we want to do, I think before I copy over some of the z-test statistics stuff, is let's go ahead and figure out this critical value. All right, so to calculate this critical value, we need to convert an area into the value that is adjacent to it, that defines it. So for that, we're going to use inverse norm. So we're going to have an area of 0.05, the mean of 0, standard deviation of 1, with an area on the left. And we're going to be using the distributions app on the NumWorks calculator with a mean of 0, standard deviation of 1, area to the left, and we're going to put an area of 0.05 here. Okay, so let's go ahead and do that. So we'll leave this, and we'll do inverse norm. And we want an area of 0.05. Oops. 0 is going to make a difference there. And now I want left tail. Paste and enter. Okay, we get negative 1.645. Let's do that on the NumWorks. So I'm just going to hit the home button. Let me hit next here. See what it shows us. Oh yeah, it gives us kind of gives us both the test statistic, the p-value. It's given us quite a bit, but I want to get more details. Anyway, let's keep going. So let me hit home. I'm going to go to the distributions app now. And let me kind of back out. We want to make sure we're looking at a normal distribution, mean of 0, standard deviation of 1. Area to the left and it's going to be in the area of 0.05. So hit execute, and we get negative 1.645, which is the same thing we got with the Texas Instruments there. So this is going to tell us that our negative Z critical value is negative 1.645. Let me use a different color to show that this was something that we just calculated. We didn't know this before. Okay, so negative 1.645. All right, now the center of this distribution is 0. So where is our test statistic going to fall? So our test statistic is negative 0.723. So negative 0.723 is going to be between 0 and this. So I'm just going to draw it right here. So our test statistic is negative 0.723. Negative 0.723 is between 0 and our critical value. So right off the bat, this is going to tell us that we're going to fail to reject the null because the test statistic is to the right of the critical value. But the other thing we need to calculate is we want to calculate this p-value, right? The p-value is the area adjacent to our test statistic here. So this is our p-value. So we expect our p-value, it's a larger area, so the p-value is going to be larger than our significance level, right? Our significance level is 0.05, and that's going to be smaller than our p-value, and we're going to calculate that next. So to calculate the p-value, we need to use normal CDF now for that. And so the lower bound is going to be negative E99 with an upper bound of negative 0.723 with a mean of 0 and a standard deviation of 1. And with the NumWorks calculator, mean of 0, standard deviation of 1, area to the left of negative 0.723, like that. All right, so let's do the NumWorks first, just to kind of change things up. Okay, so what we want, okay, is the area to the left of a negative 0.723. And let's see what p-value that gets us. 0.235. Okay, 0.235. Red. So 0.235. And you can see this area of 0.235 is greater than this area of 0.05. And this relationship we can actually visually see here and here. Right? We can see the p-value area is much larger, like 4 times larger. All right. So both of these are telling us that we're going to fail to reject. And that constitutes step 5. But really quick, let me put what the p-value score is here. That's what these calculator functions did. There we go. Okay, so step 5 is if p is smaller, then reject the nuller. But in this case, this is not true. So what we're going to do is we're going to fail to reject the null. And we're failing to reject the null, and we need to couple that with our original claim. So the alternate hypothesis was our original claim. So the alternate hypothesis is our original claim. So if we come down here, okay, we're going to fail to reject the null, and the alternate was our original claim. And where those two will come together will be this outcome right here. So we'll start by writing there is not sufficient evidence to support the claim that, and then we want to put what the claim was. The average time a customer waits on hold is less than 5 minutes. See here that the average customer wait time is less than 5 minutes. That's going to be with a 95% confidence level. Okay, so there is not sufficient evidence to support the claim that the average customer wait time is less than 5 minutes with a 95% confidence level. That is the end of our hypothesis test. Okay, so what we ended up doing is we ended up taking all of the individual parts that we've learned in sections 9.1 through 9.4, starting with converting our word problem into given information and setting up a null and alternate hypothesis and gathering as much information as that we can out of the null and alternate hypothesis, making sure that we record which was the original claim and then what tail of a distribution we're dealing with, because the tail of the distribution we're dealing with comes into play later. And we need that to be correct so that we can set up the reject and the fail to reject regions appropriately. We need to calculate the test statistic from our sample data and the p-value from our sample data. And we can use the calculator function to do that for us. Okay. And then once we sketch this distribution, we can kind of lay it all out here so that we can visually see whether we're going to reject or fail to reject the null. And then we couple failing to reject or rejecting with our original claim in order to write our conclusion at the end. So this process, we're going to be going through these same 5 steps over and over and over again in this chapter, as well as chapter 10, chapter 11, and chapter 13. So you will get used to identifying these steps. You'll get a lot of practice with it, so you'll get better and better and better with it. But this is the primary reason why in chapter 6 and chapter 7, I kept reinforcing to keep drawing, keep sketching this curve, keep sketching this curve, keep sketching this curve, and get used to labeling it and labeling the area underneath. Because you need to be able to label these areas and label this curve correctly in order to set you up to make this kind of conclusion. Okay, so that was practice so that you're not thinking about sketching this so much anymore, but you're now focusing on these regions and comparing these two values or these two areas. Okay. All right. So that's the end of this example. Let me know if you have any questions.